Hello students, in this class we shall discuss LC oscillation. That means in a circuit where no resistance is there initially, what happens? Suppose a charged capacitor which is already having some charge, let it be Q naught plus minus, is connected across an inductor of value L. Since the capacitor is already having some charge, it will start supplying current to the circuit. Then the current will be flowing in the circuit. Now let us write down the equation KVL, Kirchhoff's loop rule or Kirchhoff's voltage law. First of all, what is the voltage supplied by the capacitor? At any instant, voltage supplied by the capacitor will be Q by C. Then supply is equal to drop. Voltage drop by inductor will be L di by dt. This is equal to 0. This implies Q by C minus L d by dt of I. What is I? Of course, I is equal to dq by dt, or not? But here, if the current flows, then the charge in the capacitor decreases continuously. That's why I will be negative of dq by dt. Negative means decrement in charge. So in place of I will write dq by dt. This is equal to 0. Then Q by C minus plus L d square Q by dt square is equal to 0. Now divide L throughout the equation. So it will be Q by LC plus d square Q by dt square is equal to 0. Implies, I will write this term first, d square Q by dt square plus Q by LC is equal to 0. Now mark it as equation number 1. Recall in 11th we studied in the oscillation chapter. It's a body that executes SHM. Its equation was d square x by dt square plus omega square x is equal to 0. It was the equation of a substance or a body which was executing simple harmonic motion, whose angular frequency was omega. Then compare this equation with this one. Here x corresponds to Q. Omega square corresponds to 1 by LC. The equation resembles this equation, means here Q, of course what is x here? X is nothing but displacement of the quantity. It was the simple harmonic motion. If a substance is oscillating between these 2 points, it is the center, then at any moment distance from the center is called x or displacement x. Suppose the particle is here, so this value is called x at any moment displacement from the origin or the center point. Similarly, here you can see, here you cannot say Q is obviously not displacement, but the equation resembles, means Q also varies as x. Okay, x varies like this. It increases, attains a maximum value, then comes to 0, then again on the other side it increases, again comes to 0, like this. Q also does like the same. That means Q value oscillates. It increases, attains a maximum value, again decreases, comes to 0, again increases in opposite direction, comes to a maximum value, then decreases to 0, and it repeats this process. That means you can say Q is in SHM. Then if Q is in SHM, then what is omega value? What is omega value? Your omega square is equal to 1 by LC. Then omega is equal to root over of LC. Okay. Now come to the circuit. How it operates in this manner, we shall try to understand. Suppose initially the current, the charge is like this. Okay. Now of course the current, the charge will, this capacitor will supply current in this manner. That means current will flow in this direction. If current flows, then inductor is also an energy storing element. It will start storing energy at once. As soon as current enters, it will start storing energy. Then after all the charges are over here, the capacitor is completely discharged. Total energy will come back to inductor. Then inductor will send current in this direction also. If inductor sends current in this direction, it will charge the capacitor again like this, plus, minus. That means inductor will gradually lose energy and capacitor will again gain energy. But in this time, the direction of the potential will be here plus, here minus. Now again, once the inductor is over, it has already lost its total energy. Then capacitor will again start supplying current to the circuit. But this time this is plus, so the direction of the current will be like this. Now current will flow in this manner. Again inductor will gain energy and it will supply in this direction, again plus, minus. That means current will first go like this, then like this, then like this. It will continue this process. That's why this is called simple harmonic motion. In simple harmonic motion, the particle is moving up down like this. Here is also charge increasing, decreasing, increasing, decreasing through a zero value. Because in between the directions, you can see capacitor loses all its charges. That means in that case, at that particular instant, charge value is 0. Okay. Increasing comes to 0, again decreasing comes to 0, again increasing 0, like this. That's why this is called LC oscillation. Okay. Since the current is moving in both directions continuously. And this is the frequency of oscillation. It is going like this means, if this is your charge increases, comes to 0, again decreases, comes to 0, like this. That means it is a sinusoidal wave. So sinusoidal wave means it is having some frequency. That frequency is your omega is equal to 1 by root over LC. Okay. That's all from LC oscillations. Thank you.